Hello, geometry class, and welcome to this video on section 10.6, more angle arc theorems. Okay, so a couple of things in your textbook that I just want to go over. The theorems here like directly follow from the theorems in the previous section about the arcs and the angles that intercept them. So the first one says that if two inscribed or two tangent chord angles intercept the same arc, they're congruent. Obviously, that's true because both the black and the red angles will be half of the intercepted arc. So if they're equal to the same thing, they're equal to each other. That just is obvious. The second one says, well, okay, if you have one of each, if you have an inscribed angle and a tangent chord angle and they intercept the same or congruent arcs, then they're congruent. And again, that's that should make perfect sense because if the arcs are congruent, their measures are the same and these angles are half that measure, so they're going to be the same too. All right. Angles inscribed in semicircles, well, if they're half the arc and the arc is 180, then of course that would be 90 degrees. And if you're bored one day, just go through your textbook and try to find these cartoons. They are absolutely horrible, and you just wonder, like, what was the person who drew them thinking of when he drew them, or what was the editor thinking when she said something like, what we need? We need these really, really bad cartoons littered throughout our textbook. That's gonna, like, remember the title of the book, right? Its title is Geometry for Enjoyment and Challenge. And so maybe they thought these cartoons, that's the enjoyment part. But I digress. Okay. So this one I think is actually the most interesting theorem in the section. This says that the sum of the measures of the tangent angle and its minor arc is 180 degrees. So the angle here formed by the two tangents and the minor arc that it intercepts will always add up to 180 degrees. So that's actually like a shortcut for how to do these, but it only works with tangent angles. Okay, so why would this work? Well, they have the summary down here. If you think about drawing in the quadrilateral OTPS, we know these two angles are right here because the radius and the tangent make a right angle at the point of tangency. So I have 180 degrees split between angle T and angle S, which means I have another 180 degrees split between angle P and angle O. And the intercepted arc here is equal to the central angle. So whatever the arc is, the angle is, and vice versa. So the angle and P, that's the other 180 degrees in the quadrilateral. All right, so let's use these theorems and do some practice problems. All right, so for the first one here, we are told that PQ and PR are tangent segments, and that QR is 163 degrees. Okay. So QR is 163. So the first thing they want us to do is find the measure of angle P. Well, what we just saw was that the measure of angle P plus the measure of arc QR, that's going to add up to 180 degrees. So if we know that this is 163, then I could say that P plus 163 is 180. So that means that the measure of angle P has to be 17. Okay, so that was part A. That's a very badly drawn 17-degree angle, but if you think about it, and I know like sometimes it gives you some pause, like, well, the diagram doesn't really make it seem like it's a 17-degree angle. Like, that's true, but angle or arc QR also doesn't look like it's 163 degrees. That looks like it's more like 90 degrees or so. So the diagram was never drawn to scale. Okay, so we found the measure of angle P. Now let's find the measure of angle PQR. Okay, so since I have two tangents here, from the two tangent theorem, we know that they are going to be congruent to each other. So that tells me that triangle PQR is going to be isosceles. So let me actually just go back to getting a pen. So this triangle here, PQR, is going to be isosceles. So the base angles Q and R, have to be congruent. PQR is one of those base angles. So let's see what they are going to be. Now for this part, I'll put this over here. All right. we know that the vertex angle is P, and that's 17. So 180 minus 17, that's 163. We did that already. So the other two angles add up to 163 degrees. So I'm going to take this and divide by 2, and that's going to give me the measure of angle PQR. So the measure of angle PQR, scroll down, the measure of angle PQR is going to be, we could say either 163 over 2 or 81.5 degrees. And those are our two answers. Okay, so the next question that we'll look at says that the arcs BC and AD are congruent to each other, so we can mark those. AB is 8, BC is 4, CD is 9. The first question is, are BE and CD parallel to each other? Okay, well, we're going to use this piece of given information here. BC and ED are congruent arcs. Since they're congruent arcs, watch what angles have to be congruent. So the inscribed angle BDC and, I don't know why it's highlighted. There we go. And the angle, the other inscribed angle, DBE, they have to be congruent because they are both inscribed angles that intercept congruent arcs. So whatever those measures are, those angles are half. And according to the first theorem that we saw, they're going to be congruent to each other. And you notice those are alternate interior angles. So that means that BC and BE are in fact parallel to each other. Oh, where'd that line come from? Yes, they are parallel. Find BE. Okay, so I know it's been forever. I mean, the month of March seems like it's gone on for a year and a half. I know it's been forever, but back when we studied similar triangles, we saw this diagram before where we had the two triangles and these lines were parallel, so those would be congruent. They share this angle, so by angle, the triangles are similar. Okay, so that means I can set up a proportion. BE corresponds to 9, the way 8 corresponds not to 4. It's not the side splitter theorem because BE and CD don't have their side split. So it's the entire length of AC, which is 12. So I solve that proportion and I get that BE is equal to 6. So BE is 6. All right. And the last question is triangle ACD scaling? All right. Well, we don't know what side AD is yet. But if it matches either the 9 or the 12 of the other two sides, then we know it's isosceles. And if it's different, then obviously, yes, it's scaling. Okay. Well, think about angle D, the big angle D. That intercepts arc CB. Okay. Now think about arc or angle C. That intercepts arc BD. All right, so let's just take a look at those two arcs again. Here is CE. Here is BD. What are these two arcs made of? Well, they're made up of CB and DE added with arc BE. So by the arc addition theorem, I can see that the yellow arc CE is congruent to the blue arc BD. And since those two arcs are congruent, the inscribed angles that intercept them have to be congruent. And now this triangle has congruent base angles. And that makes that, nope, not scaling. It's isosceles. All right, so that's all for now. Hope you guys took some good notes, and I hope you have a wonderful long weekend, and I'll see you back next time.